Okay, this is section 7.5. We're looking at midpoints and diagonals of quadrilaterals. Copper sulfate is one of the many minerals and chemical compounds that form crystals with quadrilateral faces. In this section, you'll examine the properties of the sides and diagonals of quadrilaterals. All right, so what are the properties of quadrilaterals? We have one here. I'm going to zoom into it. So we don't have to draw. Yeah, Adam.
Exterior angle is always equal to 60.
Okay, you're giving me properties?
Yep.
Okay, all right, let's just go through it, and then if I ask a question, it's kind of a, it's okay. All right, number one, draw a large quadrilateral ABCD, measure the four sides and mark the midpoints with E, the midpoint of AB, F, the midpoint of BC, and so on. So here's our beautiful quadrilateral. It's been measured out. Again, these dashes represent equal signs. So if there's 4 dashes, it equals the same length of this side, which is 4 dashes. 3, 3, 2, 2. All right. Next it says draw line segments joining E to F, F to G, G to H, and H to E. What type of quadrilateral does EFGH appear to be? So I'm going to draw that here. All right, so what do you guys think? What type of quadrilateral? Tim? Parallelogram, excellent. So the two sides I believe that Tim believes are parallel would be this side and this side. Okay, good. Measure and compare the line segments in the smaller quadrilateral. What relationship are there among the length of these line segments? So I measure the smaller quadrilateral. .6, 1.4, 1.6. So it appears to be that the opposite sides are equal. This length is equal to this length, and this length is equal to this length. We'll see if that's the case later in the lesson. Let's see. Measure the interior angles of the quadrilateral EFGH with a protractor. Mark these measures on your drawing. So I would say that based on the interior angles, this angle, we'll call it angle A. Little a appears to be equal to angle B, and angle C appears to be equal to angle D. Okay, based on looking at it. We happen to have a protractor here. We'll measure it quickly. So this angle appears to be about 75. Oh, sorry, yeah. Sorry, my bad. So not 75, 115. Okay, and this angle here.
What's your math book again? Don't try that.
Also appears to be 115. So that looks right. So angle C is equal to angle D. Angle B is equal to angle A. All right. If co-interior angles formed by a transversal and two line segments are supplementary, the two segments are parallel. Are any of the sides of the quadrilateral EFGH parallel? So we have determined that these two sides are parallel, right? By looking at them, we can see that, and that is now true based on the angles by definition. Okay. Number 6. Do your answers to steps 3 to 5 confirm your conjecture in step 2? Let's see. Step 2, our conjecture was what type of quadrilateral? Yes, it does, right? It's a parallelogram. So. Sorry?
option number 5?
Yeah, we did. Are any sides of the quadrilateral EFG parallel? Yes, they are. Okay. Compare your results with those of your classmates. So we're going to assume that everyone got the same results, right? We'll see how that works out for us. Do you think that joining the midpoints of the sides of any quadrilateral always produces the same type of geometric shape? What do you guys think? Any quadrilateral. So quadrilateral, remember, is just a shape with 4 sides. I'll try to draw some different shapes here. One important part is that you have to make sure that your lines are straight, right? Otherwise, none of these properties will work. So this line would have to be not curved as I drew it. It would have to be like that. Okay? So let's start again. I was trying to draw a unique quadrilateral. Okay, so there's a strange looking quadrilateral. Let's see if we get the same results. So we're going to find the midpoints. Okay, and we're going to join them. Notice how when I move the ruler, I can keep that same angle. So we see that it does in fact create a parallelogram. Okay? Doesn't matter how strange your initial quadrilateral is, your resulting midpoint joining quadrilateral will be a parallelogram. Yeah. Concave? No.
Would it go outside?
Yeah, it would just actually, yeah, it looks like it will work. Just goes outside the concave shape. Yeah. Yep.
So do the lengths of these parallel lines have to be the same?
We're gonna find out. Let's go. Let's go to the next example. Find out right now. Okay, the next thing we want to do is show that diagonals of a parallelogram bisect each other. Okay, so they do this on Geometry Sketchpad, which you guys are now familiar with. They draw a parallelogram here, so we can see that this side is parallel, these sides are parallel, and then you can see here that they actually do measure it, and you can see DE is equal to EB, and EC is equal to AE. So this side is equal to this side, and this side is equal to this side. Okay? So in fact, in a parallelogram, if you take the diagonals, so the diagonals of course are just the lines going straight across from opposite vertices. Okay? They're going to bisect each other. Sorry. This bisects this. Okay? These sides are not necessarily equal in a parallelogram. All right? Example 2. Cody conjectured that the diagonals of a parallelogram are always perpendicular to each other. Is she correct? So we can see here with this parallelogram, so here's our parallelogram. If we were to take those diagonals, that they are not a right angle. So they do not always intersect or are not always perpendicular. Remember, if something's perpendicular, it needs to be 90 degrees. Okay? So in this case here, we can see here in this parallelogram that the angle is not 90 degrees. So two diagonals of a parallelogram don't always necessarily meet at a 90-degree angle. Okay, they don't have to. Okay? It all depends on the side length of the parallelogram, right? If we have one side length that's really long, right, that's going to increase the angle at which they meet. You guys see that? That angle is nowhere near 90 degrees. Neither is that. Okay? So finally, the last point, key concept, joining the midpoints of the sides of any quadrilateral produces a parallelogram. So midpoints here, if we join them, we get a parallelogram. The diagonals of a parallelogram bisect each other. So any parallelogram, if we join the diagonals now, they're going to cut each other in half. Okay? Any questions about that? Either of those two properties? All right.